Hi, Said and team. I will now do a second video because I did the first and actually noticed that the audio was not recorded. So in this second video, I will showcase my application to label plans. I will provide this user and password so you can use the full-fledged user account, which have all the features enabled for our purposes. So let's start. So first, this is the login of the application. For the user, I have created this account, SEISMIC, and the password I will send to you by email. Upon login, you will notice this menu, which you can check for all your projects, and you can edit the projects. The control panel and the other stuff is not important at this time. For the project viewer, you have already two projects. The first one is a project that I developed when we were creating the project guidelines about 6 months ago. So here you can see, some of the features of the application. Here is the 3D viewer that it's not interesting at this time, as it is intended to visualize the 3D structures whenever we are providing the height for each floor plan. So it's not the case. So I prefer you to close this dialog so you save some memory. Here is two buttons, new floor and edit project info. So the project is basically a collection of distinct floors. So each floor is compressed by an image, the floor plan, and a set of objects. Let's say the walls, the slabs, rooms, and non-structural elements like wall, windows, doors, kitchen appliances, bathroom, and other stuff. In the project tree, you can see all the floors, in this case L1, with a certain category, and all sets of objects. So if you right-click on each element on this project tree, there is a menu when you can create new objects, let's say wall, slab, rooms, and check other information. In this case, this account is not the owner of this project, you cannot edit or delete, but when you create your own objects, then you can edit them as well. So if you left click the floor, in this case, you can check on this canvas, the editor. Here you have a set of tools. In this case, these are basic tools because we are now in viewer mode. So you can zoom in, zoom out, measure, distance, and angle. But when we are creating objects, you will have much more tools. Here you have a minimap when you can hold and drag, so you can check where are you in a large plan. With the scroll, you can scroll in and out, and that's it. So here we can visualize all distinct set of rooms, distinct set of walls. So a wall in this platform is a collection of a set of points or wall joints and segments. The points are the crossing, the intersection between wall segments, and the wall segments are rectangles that connect two distinct points. So in such a case, we can assemble a wall graph. So we can compute all distinct properties, and traversing this data structure is kind of easy. So here in this menu, you can visualize both the structural walls or partition walls. These are two categories, but the objects are the same. The slab, which is the area, the complete area of the plan. Each one of these rooms, you can check that whenever we click any object, we are redirected to that. So we focus each object. And for objects, in this case, we have some bathroom objects, doors, kitchen appliances, sinks, and some windows. So that's it, like the preview of a project. So in this case, creating a project is really simple. All you need to do is provide a new label, which is up to you. I just created the SEISMIC 1, the true, or then you can go from 3 and above. A code is an optional number that you can apply, and then you can perform some queries over it. In the description, I will suggest you to place some description of your own, like some categories of it, so you also can perform some queries. For project date, I suggest you to place the date that you are labeling the project, and all this other stuff like address, location, and these properties are completely optional. And in this case, we will not use these because these are some properties that are introduced to create my own dataset, and these are some structural properties like period or mass. So it's not important. When you finish all this information, then you click Save Project, and then you can start editing. As I have already created a project, so you will check for the SEISMIC 2. I created 2 hours ago when I noticed that I was not recording audio. So here, in order to create a new floor, what you have to do is I will create a new floor, and then I will delete that and continue editing the existing floor. So in order to create a new floor, what you have to do is click on this button, New Floor, set the floor type. In this case, it will be architectural. It does not matter about which type are you using, just architectural. There's a distinction from structural because of my thesis and what I aimed for the database itself, but it will be architectural in this case. For floor category, you can select the proper category of the floor, let's say education, hotel, house, medical, office, etc. For label, it's the name of the floor that you are creating. It's completely optional. And the other really important object is the image. So for the image, you can select any PNG, JPEG, or a PDF. I suggest you to upload a PDF image, and the server will automatically convert that to the most suitable representation of an image for that PDF with the proper color, the proper transparency and dimension that I have figured out that better represent a PDF image. So in this case, I will look for the plan that you provided me. I guess it's this one. So I will upload this PDF, and the server will automatically convert that to a PNG. And you need to, well, it will automatically be downloaded, and then you upload that PNG if you want to, let's say, rotate it or perform other stuff. So I will save that in downloads, and then you just upload that PNG, which is really large. You can tell 9,000 pixels, but that's the optimal width that I figured out to use. Then you can also check for plan in fit, if that's the dimensions in the plan itself. Let's say a category, house, and also it's required the label that I will place as floor 1. And then you create a floor. Now, in this step, you need to define the scale of the plan. So for the scale, you need to click 2 distinct points, let's say this one and this one, and then you need to define the measure in meters. In this case, it will be 285. So then you push that to a certain average. So in this case, I have an average of 457 pixels per meter. The idea is that you create another measure so you have a much more consistent scale. And let's say here, this point and this point, 285. If I push to average, you can check for all your measures. So you can tell that there is some set of difference between each scale. So I will go for another measure. I suggest to go for 2 or 3 measures to get the best performance. So in this case, it will be 3, 4, 7, 5, and push to average. So then you have a much more consistent average, and then the offset is not important because it allows you to place one plan in top of another. So in this case, I just check for this base floor and then save. You also can move that and it will have another offset, but it is the same plan, so it does not matter. And that is the floor creation. Now, I will delete this one because it's not important at this time. And I will continue editing the first floor that I labeled, so we can check how does this software works. So the most important stuff when it comes to analyzing plans and labeling them are the walls, because the walls allow you to partition between distinct rooms. It also serves you to recognize objects between them or embedded in them, like the walls, or the windows and the doors. And also, as they convey us the room partition, they allow you to segment all the room instances. So, and also the walls delineate the perimeter of the building. So that's why these objects are really important to start with. That's why a good portion of time will be invested into labeling walls. So for labeling walls, this software allows you for 2 ways to create walls. First one is the slow method that I will show you how does it work. And then we will check for the fast way that I recommend. So then you can decide what is the best for you. Okay, so for the slow method, you first need to create a new wall object. For that, you can click these shortcuts, new wall or new slab, or you can right-click on this floor object, new wall, or you can open all these dialogues. Let's say you want to create a structural wall and right-click new wall. So the new wall, this button is the same as this one. If you click new wall, you will create a new object, which will be the container of the points and the wall segments. That is the rectangles. You can set the color, the material, and the category, which in this case is structural, and you create the wall. The color and the rectangle color and point color is just visuals. So we create a new wall. Now we have a new wall which is completely empty. So in this case, we need to create the points. So as I said, the point is the wall joint, the wall intersection, and the rectangles connect between points. So let's start with this new wall. So we create a new point by clicking this button or right-clicking this container or right-clicking this object that we created and new point. Here we can check that the new wall 6 will be the container of this new point. So in order to create a new point, you just need to click the new coordinates in this plan, and you will see the new object. If you click, you can drag this new point, and you will notice some anchors, which are the other objects that we have created so far, and they will serve you as a guideline to create a new coordinate. So use anchors a lot. They are very useful. So in order to do that, you just hold this object and move it around the plan, and you will check for these green lines. And it will automatically snap in this new anchor. So you can create your object by maintaining the same position of nearby points. So here we have a lot of tools. You will use a few of them. For example, this one basically creates a bounding box of all the points that you have introduced and make it rectangular. So this is the most appropriate tool for this purpose. But also you have creating a new point from a certain radius, moving all these points, deleting them, like resetting the figure, moving, and all other stuff like you can check later. So let's say finish. So here we have created our first point. Now we need to create another edge point, which will be this one. So I will use the anchors. And also you can check for the dimension if that makes sense. And finally, this one, a 0.3. So using the anchors is really easy. You just need to hold, and I will make it rectangular. I will create also this new point using the anchors. New point here and no, here. If you use the arrows in the keyboard, you also can apply some fine tuning. This one, and finalize making it rectangular. This point also. And what else? It's a complex wall, as you can check for sure. This new point. Making it rectangular, and this point. You can notice that if you have many points in the plan, the snapping will be easier. So the first clicks that you are introducing will be the most complex, as you need to just try to make it perfect and align in the image. So we have created all of new points of the wall. So now we need to connect them. So to that, you just click on this rectangle button or right click into this wall, new rect, and you need to specify 2 points where you will create your rect. The system will automatically provide you 2 guess points, but just to be sure, you also can click which point you want to connect. For example, this one and this one. And the system will also provide you a tentative thickness, in this case, 30 centimeters, but also you can specify a better approximation of this thickness. And it will be based on the height of the surrounding points and the access that are you willing to do. So in this case, we will go for it and create a new rect. And here we have our first rectangle segment. Now we need to just proceed and reconnect all the points of our wall. Let's say this one. We know that this is 10 centimeters, so I will just select this, new rectangle over it. And sometimes before P5, this short is P6, so we are connecting P5 and P6, P5, P5, and P6. So you can notice that it is kind of slow going for this method, but it allows you for a more granular control over all the objects that you are creating. So you can you can expect that these guesses can be correct, but not sometimes. The system will try to connect like this point with this point. So in not all cases, this guess will work, but in the most cases, it will have a correct solution. So we have finished our first wall. So you can tell that the geometry of the wall is complex, but we have figured out a really good approximation of our wall. So this is the slow method to create walls, but there is a much faster way to create them. And I will show you right now. So the second alternative you have to create walls is to create them from polygon. So in this method, you only outline all the perimeter of the wall by clicking all the points, and an algorithm will automatically segment such object, check for all the intersections of the given geometry, create new points that hold all this figure, and reconnect and connect all the joints, and do that all automatically. So that algorithm is kind of complex, and it has its issues, but for the most cases, we have noticed that it works really, really well. So we will go for a new wall from polygon, and let's create this wall, which is really simple. So in this case, we just only, and also use the anchors, so it will be much more easy to create this wall. So here I will create this. So you notice that it's really simple to create a wall using this technique. Use the keyboard. There we go. And I guess that there is only one remaining. Okay, so we have all the points clicked, and if we finish, the system will automatically create this new shape. So there are some points that were automatically generated, like this that serves as the intersection of the new point, and all these segments in color are the new wall segment propositions. So then you check if that works and then generate. And automatically it will create all the objects in this wall container. So this obviously is a much more simple method to create walls, and really fast. So I will create a new wall from polygon, create wall, and I will simplify this wall by, I will start from here. Okay, you can go on any order. You don't need to move in clockwise or reverse order. Any order might work. Okay, so and finally this point. We finish and generate. And I need to do this order. So I suggest that you use this method, which is much more fast, this faster method, and really works well in most cases. Notice that I'm using the touchpad, so even using the touchpad allows for good results. Okay. There we have, and you can check that I just swapped 2 points, so we can move those and fix the figure. It does not matter. Finish. You need to be consistent in the order that you generate the geometry. So now we will go in this direction. Using the anchor points. Each time you create a new coordinate, you generate a new anchor. So try to have good objects placed, or otherwise you will encounter invalid anchors in the system. And finally, this wall. It should be the last one. Notice that this algorithm is kind of complex, the one that automatically gives you the geometry. So if you expect or you encounter any issue, you can send me the geometry of the wall or the plan and which wall it belongs to, and I can review the algorithm. So I introduce more classes, because this algorithm actually is created using distinct combinations of possibilities on which each joint or each edge is configured. So in this case, the software recognized the edge of class J plus, class O, or distinct types. So the more classes we have, the better results. Uploading. Also, there are some thresholds in the application that ignore segments that are less than 5 centimeters. So in this case, the algorithm ignored this portion of the wall. So if you, for example, want to hold this object, what you need to do is you can delete any point. If you delete that point, the segment will also be deleted. Now you create a new point, P6. For example, click this one, make it rectangular, create P7, and create a new rectangle from P6 to P7, and finally a new rectangle from this point to this point. And then you have the complete figure. These thresholds are really important to preserve the logic of the algorithm. So expect that this is considered as noise, and that's why the system ignores that. And also, I think that this is also a wall. So I will also create a new point, let's say here. So you can tell that sometimes it is complex to recognize our own object in the plan. And that's why having a guideline on which objects are expected is really important. Otherwise, you can face some labeling issues. And that's why labeling plans is so complex, because the possibilities you have to classify objects are vast. For example, in this case, what it is a wall, it is a window, it is just a hash, because it is an inverted wall, or it's a wall, but it is not fully connected to the slab because it might have some electronics or something like that. So sometimes there is no sufficient labeling or annotations for this type of object. So in this case, I just consider that it is not a wall, but it could be. And that's why having a good set of guidelines will prevent you confusion over the labeling process. Also, these are walls, but these are partition walls or internal walls. So I will also add a new partition wall. Why not? with another color, let's say this color, and I will click. Distinguishing between partition walls or structural walls is not that important. I mean, these are the same objects, but they only differ in their category. Or it's if you really think about their bin, which they belong to. But in terms of the polygon, it's kind of the same. Okay, there we have one. We have this also other really simple polygon, which is just a rectangle for this partition wall. Okay, and what else? This one, neuron for polygon. Although you notice that this is a kind of a simple method for labeling plans, you can tell for sure that this takes time. It's a long, tedious process, very expensive, but really necessary to have a really good dataset. And also, it is important to distinguish first which are the objects that are you aiming to label, because not all objects are important for each task. So in this case, I will label all the objects in the plan, but maybe labeling doors or windows are not important. Okay, so I guess that we have finished. Oh no, just to be concise, no. Let's finish all the walls. Oh, here is another wall. Let's finish with this. I don't expect that it will work because this is a really short wall. I don't know. I guess that the algorithm will not recognize. Yes, you can see that this just omitted this step. It's basically noise 2 centimeters. Okay. Now, this is basically the operation to label walls. Now, another important stuff is the slab, but I prefer to leave slab at the latest part of the process. Now, we will create some windows for this plan. So for that, you can right-click into window, new object, define which type do you want, for example, window, and the label, and just create object. So for windows, it's really easy, and you only need to click the boundaries of the polygon, for example, this one and this one, make it rectangular and finish, and that's all. So depending on how do you define a window, you also can tell that maybe this one is the window, which could be, and it will depend on your vision and your thoughts. So that's why distinguishing and aligning the properties of the plans and how you will label that is really important. The thing is that you need to be consistent. Now, I will consider that this is a wall from this point to this point. And also there is a shortcut, so you don't need to repeat the process of right-click a new window. You just on Mac type Control-Option-N, and you will repeat the latest object that you have created, in this case, a window. It's much more easy. There we have. And here we have another wall. On average, a plan like this takes 20 minutes. So this whole image will be an hour of work. Okay, I think that we have all the window. So now some doors. Let's say some interior door. So for doors, you have two choices. You can click all the points of your door in this way. So you create the semicircle with not the best accuracy, but sufficient. You don't need to be really have perfect geometries, but this could work. Now, Control Option N. And the other alternative you have to create doors is just to click 3 points of the semicircle and click Make Semicircle. And you will have this fancy semicircle really easy. Now, again, Control Option N, these 3 points of the semicircle, make semicircle. You know, really easy to create. What else we have? This door, this interior door. Oh, make semicircle. And another 2 doors. Here and here. Make semicircle, and we move this. This another semicircle. And finally, we have this exterior door, I guess. Or obviously it have another color. Okay. So we have finished all our doors. So let's place some rooms. So the room is kind of the same as the other objects, but they are hashed or they have internal color. So for room, it's the same. We click the room and their category. This case, we have many depending on the category of the floor. So if we have medical or we have shopping or office, we will expect some common categories. And if no one of these categories work, then you just click on generic room. So let's place some bedrooms. So again, it is not important that the figure is perfect. So you can align those using the grids, or you just click by a site where you think that it should belong and just finish the room. So here we have our bedroom. You can also click Control-Alt-N to repeat our previous room. So I will just make it fast. You can draw the rooms by the internal side of the wall or the exterior side. It depends on your choices. At the end, it does not matter so much. We have another room here. So let's, and also, for example, you can use this interior side of the door to represent the room. But again, it does not matter in the end. We go here, this point, and this point. What else? We have a kitchen, so Control-Alt-N, and we change to kitchen. Okay, so let's imagine that here is the boundary of the kitchen. And we have some bathrooms. So place bathroom. So in this case, I will use the interior side of the room. And it will depend on what guidelines you have created to label the plants. One bathroom here, one bathroom here. And I will skip this void of the door. And we have our final bathroom here. And we have a hole. So let's open a hole. And I will also use all the space. And that's it. So we can finalize our approach by adding some extra objects, for example, some bathroom objects. We will add a toilet. You can draw just a bounding box, or you can add the entire shape of the object. If and only if toilets are necessary for your labeling purposes. If not, you can skip these objects. Maybe we are only interested in the room partition and the walls. So you need to double check it. We have another toilet here. We have some sinks. Basic shape to delineate the sink. Another sink here. You also can place a bounding box, for example, in this case, simple bounding box. And we have another sink here. That's weird. And what else? Okay, so we need also some showers. Here we have a shower. This is the second shower. And our third shower. And we also have some kitchen objects, for example, a sink. And we will create only a bounding box for it. We have a refrigerator. We have an oven. If you need more categories, just let me know. And a base cabinet. Again, you don't need to have a perfect geometry for it, as obviously the models are not perfect, but just to make you an idea. Here we have notice that we don't have any anchors of this type because only the walls serve as anchor. Other objects like doors, windows, or rooms do not share their points to anchorize the other objects. And that's it. With this approach, you are able to create any set of plans. So this other example I did created in a very simple and the same process to recreate this plan. So here you can check that the dimensions are really similar. There are some differences because this side is 10 centimeters and we have here 3 meters, but these 3 meters also consider this size. So we have 40 centimeters span, under length is 334. You subtract 40 centimeters and you get the original size. So that's it. That is the way you create new plans. So if you encounter any issue, please let me know. This software is really complex, so any feedback you require, I can provide it to you. And then when it comes to use the API for downloading and parsing these plans, I also will show you some Jupyter Notebook example in how to use and parse this data. Thank you.